Greetings and good day to Dr. Faharna Aziz. Today, my group and I will be presenting on our engineering overview assignment. Before we start, I would like to introduce my group members, which is Iqbal, me, Natasha, and Elianis. So for the topic of our assignment, previous slide, please. So the topic of our assignment is role of professional engineer in chemical field. So before we go into details regarding our assignment, let us first see what is chemical engineering. So chemical engineering is a field that involves the production and manufacturing of products through chemical processes.
Okay. So the topic assignment is roles of professional engineers in chemical field. So what is the role of professional engineer? So the first is chemical field establish safety procedure for those working with dangerous chemical to ensure that no accident during working time. So next, estimating production cost. For example, if there are any equipment or processes that can be combined into one process, so engineers should be combine it to reduce the cost and at the same time can increase their productivity. So number 3, develop processes for separating component or liquid and gases or for generating electrical current by using controlled chemical processes. So next slide, please. Number 4 is troubleshoot problem with manufacturing process. And number 5 is conduct test and monitor performance of through production. To ensure that all equipment performance in tip-top condition. And lastly, design and plan the layout of equipment. But for me, engineers has greater risk because if anything happen in the site, all responsibility lies at professional engineer. So I will pass to my team member.
Okay, pathway to become professional engineer. There's 2 ways, which is to become professional engineer, which is IEM or BEM. IEM is Institute Engineer Malaysia, or BEM Board Engineer Malaysia. So for IEM, usually for unrecognized engineering degree or foreign engineer. Other than that, BEM for if be professional engineer, they need to sitting PAE, which is Professional Assessment Examination. This photo of the pathway how to become a professional engineer. Okay, next fields of specialization in chemical field, which is oil and gas, biotechnology, health and safety, and toxicology. So oil and gas usually they were at offshore and onshore, where they dig natural gas and oil in the ocean. Next, biotechnology usually in lab, which is technique that utilize biological system to develop operate different products. Health and safety, which is a combination of knowledge of engineering and health and safety to develop procedures or design system to protect people from injury. While toxicology is works with chemicals and other substances to determine if they toxic or harmful to humans or other environment. So next, to Natasha.
Okay, so for this section, the chemical engineer who changed the world, we actually choose Fritz Haber, a German chemist who received the Nobel Prize in Chemistry in 1918 for his invention of the Haber-Bosch process, a method used in industry to synthesize ammonia from nitrogen gas and hydrogen gas. He is also known as the father as the father of chemical weapons for his years of work developing and weaponizing chlorine and other poisonous gases during the World War I. And because of this, when he actually received the Nobel Prize, it was quite controversial because many consider him a war criminal. So back to Haber-Bosch process, it was actually the first industrial chemical process to use high pressure for a chemical reaction. It directly combines nitrogen from the air with hydrogen under extremely high pressure and moderately high temperature. A catalyst made mostly from iron enables the reaction to be carried out at a lower temperature than otherwise would be practicable. Yeah. So the lower the temperature and the higher the pressure used, the greater the proportion of ammonia yielded in the mixture. Okay, next. So how does actually Haber-Bosch process impacts the world, or how it benefits the world? So first of all, it helps feed the world. Before we start, did you ever see a magician make coin out of thin air? Of course, no, it's impossible. And here we have brilliant a German chemist, Fritz Haber, who actually made food out of thin air, or as German would call, Ruf à Luft, which means bread from air. So how it is possible? Right, so first of all, it won't be an exaggeration to say almost 40% of the world population today owe their lives to Haber process, and also over 50% of nitrogen in our body actually started out in a Haber process unit. So before the development of Haber process, ammonia have been difficult to produce on an industrial state. So ammonia is only produced in a small scale. So the method used earlier is the Birkeland-Eyde process and Frank-Caro process, which is inefficient. So throughout the 19th century, the demand for nitrates and ammonia for use as fertilizers and industrial feedstocks had been steadily increasing. So the main source of ammonia and nitrate back then was mining nitre deposits. So at the beginning of the 20th century, it was predicted that these reserves could not supply for future demands, and research into new potential sources of ammonia became more important. Although atmospheric nitrogen is abundant, which comprise 80% of the air, nitrogen is exceptionally stable, so it cannot react with other chemical easily. So converting nitrogen into ammonia posed a challenge for chemists globally. Ammonia was first manufactured using the Haber process on an industrial scale in 1913 in BASF's Oppau plant in Germany, reaching 20 tons per day the following year. So this is the first production of ammonia in a vast amount. Okay, so the world before Haber and Bosch process was only able to support 4 billion people with farming techniques of the time, like simple farming technique. So once this process was created, once the process for creating nitrates for use in fertilizers was widespread, the human population began to skyrocket. The current world population is over 7 billion and growing. Most of those extra mouths are being fed with food generated from Haber and Bosch's invention. Crops can now grow in areas where they never grow before. Despite the increase in global population, the number of people who go hungry in the world is also on the decline, which means the number of people going hungry is less, according to the UN. So that is how actually Haber-Bosch process can help in feeding the world population. Next, production of inexpensive ammonia in a large amount. So how it is possible? Iron catalyst is used in the Haber process for synthesis of ammonia because iron is not easily poisoned as compared to other catalysts. Catalyst's main role in the industrial processes is to increase the yield of the products. So that's why using Haber process, the production of ammonia is more. And because of the presence of the catalyst, the rate of reaction can be speed up. So this result in less energy use, which also leads to less cost. So that's why the production of ammonia used in Haber process is actually cheaper. Yeah. And a little bit story on Fritz Haber actually. So Fritz Haber, as I said before, is known as father of chemical weaponizing, chemical weapon. So he will not only invent the chemical, chemical weapon, for example, like the chlorine gas, but he will also promote the use of it to the Western Front, which is the military going to war at that time. So because of his action, it caused his wife to get distraught, and at the end, she took her own life. And during the 1930s, when Nazi took power in Germany, Fritz Haber actually got kicked out of his job and also the country because Fritz Haber is actually a Jewish. So although he made a very great invention, contribute to the country, but this cannot outweigh his Jewish roots. So yeah, he got kicked out of the country, and at the end of his life, he died at a Swiss hotel, alone and broken man.
Okay. So this is the proof. Our group interview Mr. Kamaruddin on Wednesday. So anyone have any question? I think that's all from us. Thank you.